Hello, very good evening, guys. So we'll start session today. I hope you guys have must have gone through the previous sessions. I have already covered basics of machine learning, then linear regression, logistic regression. So I would really appreciate if you can just go through all this algorithm because it's very important to be in same page. So today, all right. So today I think there are already number of viewers have already reached. So today we are going to learn KNN, which is basically also called as K nearest neighbor. And this is our fourth session. So I hope you guys are enjoying and you guys are practicing. So since I have already uploaded all this code and will you can refer all this YouTube live, and after that we'll upload all this code in our GitHub. So you can probably go and see. All right. Okay. So yeah. So basically, what is the objective of this kind of machine learning, which is K nearest neighbor? So I would say K nearest neighbor algorithm is one of the most fundamental and powerful algorithm to understand and when and how we use all this algorithm. So we can see in our today's class. All right. So basically, we also called KNN as a classification problem, when we deal with the binary classification, let's say 0 and 1, or maybe more than when we should have at least at least two variable or maybe uh, more than two variable, like the n number of variable we have, like n number of classes specifically, I would say, then we can use this particular algorithm. So when we have the little knowledge about the distribution of data, when we don't have the any knowledge of distribution of data, like how the data is spreading and what exactly we need to do, so the KNN performs really well in that particular scenario. All right. Yeah. So today we have the session of, because I will just cover this particular part KNN and will quickly go through the code. I will show you how we can classify the different groups. So I think it will take around 1 hour, not maximum 1 hour, 1 hour, maybe 15 minutes or so. Then we can quickly have a discussion session if you guys have any doubt, so we can quickly answer your queries. All right. Yeah. So this algorithm determines the value of unseen data point based on the value of its neighbor. So what do you mean by that? Like unseen, when we have the lot of data points and we don't know exactly what to do, and the data points is in very jumbled and very unlabeled manner. So in that particular scenario, we classify our problem. Like we classify, we have to distribute our classes, considering the similarity. So this is the particular thing which we are going to learn here. So in KNN, we basically calculate the Euclidean distance. So Euclidean distance means one data points to another, like how far it is, whether it is a neighbor data point or maybe the data point is very far from each other. Okay. So so I think my voice is bit low, so you guys can ping over here. Just let me check. Yeah. So depending on how many points are in vicinity, it classifies the new data point accordingly. If your our neighborhood, we have the two different data points or maybe more than different points. According to the similarity, we can club them together. And KNN can handle binary classification, as I told you. and maybe sometimes beyond binary classification, maybe when we have the n number of classes, right? So what is the difference between KNN and K-mean? So it's a very small difference, like KNN, which is the nearest neighbor, like whatever the data points we have the nearest, so we can club them together, and whatever the distance between them, like from one data point to another, okay, we can calculate as a mean. So how we can do, we'll see in a visualization. So no need to worry about that. So let's say, for example, like on a very layman term, like if I have mentioned one example here, suppose you are a class teacher and you got a new student and who is going to admit in a particular class, and so you want to find a proper friend circle for the new student, right? Like since you want to place the students with similar student, like suppose you look at certain characteristics like aptitude, interest, affinity towards sports, something like that. So based on these categories or maybe a characteristics, you place the students to its nearest neighbor. So this nearness is measured basis on this criteria. So this is also called as KNN. So in KNN, like when we talk about the KNN algorithm, we can also call it is the most important algorithm to learn, as well as we call as a lazy algorithm, because when you don't have any prior knowledge of any data, so you can specifically build this particular technique, and it always perform really well. So the purpose is to use a database in which the data point are separated interval classes to predict the classification of a new sample point. So what exactly this mean? Like when we have the two different data point, so we can club them together in a one neighborhood, like let's say a class 1. Like suppose if the we have just like given the example, let's say if the student very studious and he wants to join in a particular section where all these people have the good aptitude skills, so we can put that particular student into that group. And let's say if the student is more curious to learn new skills, maybe a drawing or sketch or maybe a painting or maybe some extracurricular activity, so we can specifically put that particular student in a class 2, and so on maybe like let's say if the student is interested in any sport activity, so we can particularly put them into that group. So according to the behavior and the characteristics, we can club them together, and we can classify, and we can cluster them. Yep. Yeah, so therefore, you can say, we can also build a regression model here. Specifically, we approach when we have the classification problem, but a regression model sometime can also perform really well. And KNN could and probably should one of the first choice for any classification study when we don't have any prior knowledge about the data distribution, like how the data is distributed among any group, or among like whenever you have given the data and there is no such specific distribution and you don't have any prior knowledge, so it is recommended you should use always this KNN. And like how it work and why it is important, I will let you know. And KNN algorithm is also based on feature similarity, as I told you, like how closely out of sample feature resemble our training set determines how we classify a given data point. So let's have a look on our visualization. Yeah. So if you can see in this right hand side particular picture, like for an instance, we have a two given class. One is K1 and K3. Sorry, K1 is which is like value of K, and we have the two given class 1 and class 2, wherein the class 1 is a blue squared and the class 2 is a red triangle, right? So when we approach our classification, if let's say k equal to 3 outside circle, if you can see like k is equal to 3 in outside circle, it is assigned to the second class because there are two triangles and only one square inside the inner circle. So if you can see if you can have a look of this thing, like this is the first class, so you can able to see there are two triangles, two red triangle and one that is a blue squared. Okay, so we can specifically, because since the majority of the triangle and the red triangle is in class 1, so we can substitute, like we can group them together in this particular class. And similarly, like if you take another example, let's say K5 or maybe a K3 or whatever it is, and it is assigned to the, like how we decide K5, K1, K2, K3, that I will discuss in the next visualization. But here you just have to understand like how it is clubbing together, like how we can put them into a specific particular, like let's say a group or maybe a cluster. So if for example k equal to 5, it is assigned to the first class, like three squares, like you can see three squares, 1, 2 and 3, versus two triangles outside the outer circle, like let's say 1 and 2. So in this given problem, so like we have the two classes here. One is this one, the outer one, and one is the inner one, which is this one, correct? So like, and like in a real world example, like when and where we have to use all this technique, like let's say you are an individual and you want a bank loan. So would an individual default on his or her loan? Is that person closer in characteristics to people who defaulted or did not, like default on their loans? Like how the bank will give you the loan if you're a defaulter. So how the bank will identify, suppose in your prior history, and if you're already a defaulter, like if you have taken like a couple of loans and you didn't manage to repay them, so in that particular scenario the bank won't allow you to give any further loans until unless your credit score is really good, and if you do not completely pay the full loan amount with interest, whatever the loan is currently running. So that is what, when this like in the finance, like in the finance real life problem, like it is we use like this KNN very widely. So what all are the pros and cons? So if I can talk about the quickly, so like since we have learned in logistic regression and linear regression, so it is based on the assumption, because we already have the given data, we have the more clarity on the data. So that is why we have to come up with the assumption. But here we do not have any kind of assumption, so no assumption about data, because the data is very unlabelly distributed in a circle. Like for example, for the non-linear data, it performs really well, right? And like it's a really simple algorithm to explain and understand. It's not difficult, because if there is a two or three different class, so we can easily identify, okay, this is the similar characteristics and this is the another characteristics, so we can just differentiate between them. High accuracy, yeah. So this algorithm will always give you the high accuracy, which is our ultimate goal, which is our ultimate approach when we build any model. So it is pretty high but not competitive in comparison to better supervised learning model. So since even though it is high, but it is not very competitive, because mm, we just don't look for the only accuracy. Sometime, because let's say in the banking sector, when accuracies really matter, but not always. Right, in the last session we have discussed about the logistic regression, so where we talk about the specificity and sensitivity. Like what if you predict wrong, like what if the customer is non-diabetic, and if you predict like he's diabetic, even though like the accuracy is really high, but it doesn't matter because you have wrongly predicted, right? So for every approach, so it is very important to decide which kind of problem you have to build, which kind of uh, model and which kind of approach. So it will automatically come with the practice and with the more experience when you gain in data science techniques. Yeah, because we will learn in our next class, there are a lot of other models which performs really well, like let's say random forest, SVM, and maybe a clustering techniques. So that is why it is, even though it is good, but it is not very competitive. But yeah, we can definitely say it is a very versatile, useful for classification as well as regression. But normally when we have the regression problem, so we'll specifically look for linear regression or maybe logistic, but we don't approach for KNN. But yeah, you can do that. And what is the consequence? Like the consequence basically the computational expensive, because if you have a huge data, so you need a very good computer which we have the the good RAM to run this model, because it will take a lot of time, because it stores a lot of algorithm on a training data. So we need a high memory for that, and stores all or almost all of the training. So in our database, like it store all the data, all the data set, all the data point to a given a training data point. And prediction stage might be slow with big N. Yeah, when you have the N, like what is N, how we decide N, that I will discuss in our next section. uh so the N, like when you have the N1 or N2 and let's say N7, it is pretty easy to distribute. Well, what if you have a N like 1,000 and you have 100, that means 100 different clusters, so it is difficult, right, to predict anything. And sensitivity to irrelevant feature and the scale of the data, this is also another consequence. Okay, so now when do we use KNN algorithm? So KNN can be used for both classification and regression, that I already told you. And however, it is most widely in the classification problem in the industry. To evaluate any technique, we generally look at three different aspects. So these are three different aspects. First one is easy to interpret output, that is fair enough. Calculation time and predictive power. So these three things we always look upon. So if you can see, let's take in quick comparison between these different problem like a logistic regression, random forest, and KNN. So I would place. So this is an assumption. This is again assumption. This is not a proven thing, but yeah, we specifically easy to interpret output. So when we have to achieve our output, when we have to specifically look for the output. So random forest performs really well. That is why it is given as one. Then followed by logistic regression and KNN. And when we talk about the calculation time, so random forest again, it has the very high accuracy and the high less time taking like performance. And after that maybe a cart. So cart, like basically when we have the different that we will discuss later. And KNN and logistic regression like third. And but the predictive power, which is pretty good enough in KNN and regression compared to, you can say, random forest. All right. Like KNN algorithm, fares across all parameter of consideration. It is commonly used for the better and low calculation time, which we can say. If you can see, the calculation time is, it's fairly good, not bad. And how does the KNN algorithm work? So, like, since I have already discussed you in this particular graph, but this is not give you the very clear picture. So we'll take another example. Like, let's say here. So to understand this, let's say this red circle. We have the three different data points. One is a red circle, one is a green square, and one is a blue star. So it is very easy to identify the outlier here, right? So this is more or less, this is outlier. But since like this is an outlier, but it is a neighborhood in the red circle. If you can see, like it is quite nearer to the red circle. And if you can see like those data points, so in a like in a visualization, like it is actually we can see like it is quite closer. But what if it is a real life scenario, then maybe this data point, this is some data maybe in Delhi, and this is some data point maybe in Mumbai. So it is like quite far. But if we talk about, maybe this is quite close, and this may be in a particular city. Like suppose this data point is related to some person location, like in, let's say, in Mumbai. In Mumbai, let's say, like in Powai, and maybe this is in Bandra, and this is maybe in Virar or something. So it is quite close. But if you can look upon this data point, so this is actually far. This is maybe a different city or maybe a different country, something like that. So like the KNN algorithm is the nearest neighbor we wish to take the vote from, let's say K3. So this you can this is the hyperparameter which you can decide by your own, like let's say K3, K4, or K5. But here in this scenario, we have the three different data points, like 1, 2, and 3. That is why it's we have specifically mentioned K equal to 3. Hence, we will now make a circle with the blue, like BS as the center, just as big as to enclose only. Yeah. So blue circle. If you can see, like we can club together of all these three. let's say if this star is like somewhere here, or maybe somewhere here, or maybe somewhere here. In that particular scenario, we don't consider this like star, because it's a complete outlier, so we can drop. But sometime outlier, you should, or you have to consider outlier, because it can make a huge difference. Like what if this person is a delegate person, and like like if the bank is not giving him loan, but in the terms of economy, like he has to change, or he has to done a remarkable job in his prior experience, so we cannot drop this particular person, right? So we should consider this person when we are giving a loan to any customer. So this is one cluster. This could be one cluster, but since the data points is too far, so 0 out of 3. But here 3 out of 3. So because, so the whole idea is we can decide our cluster according to the nearness. And if we talk about the mean, the k mean, so the distance between here, that is called as Euclidean distance, like how far it is from one data point to another. And the mean is from center to center, it can be anything, like how far it is from its mean, like how far it is from its center point, its centroid maybe. The choice of parameter of k is very crucial in this algorithm, yeah. So how we can decide, it has a 3 data point, it has a 4 data point, it has a a 4 different data points, like k equal to 3, 4, 5, 7, whatever. So we'll take a quick example of Wilson editing here, like remove points that do not agree with most of their k nearest neighbor. So if some data points doesn't make any relevance, so we can just ignore them. Let's say this is the original data. So you can say like a lot of red dots and a lot of blue dots here. So in this data, you can pretty much classify them. You can pretty much classify them in a two different group, but actually it is not a two different group. Like here it's mentioned like K7. That means it has a lot of different other data points as well. Like maybe it's a, let's say star, bullet, asterisk, or it could be anything. So if you can see, there are few blue few data point which is in this red zone. You can see here, and it can be many like other things, like maybe here, maybe here, maybe here, or it can be anywhere. Similarly, in the right hand side, if you can see, there are one red point is here, and it could be maybe here, or like it can be anywhere, right? So edited NNN. So what we have to do, so now we have to specifically distribute, like how in the naked eye it is very difficult to distribute this data point. So that is why the KNN performs really well. When you have this particular technique, when you have this particular algorithm, so it will give you the more sense when you distribute, or when you classify the distribution into a two or maybe a more different groups. Correct? I think now uh, you have pretty much understood what all I'm talking about. Yeah, let's say this is the original data and this is the actual. So we, in this data you can easily identify, okay, like this is the red and this is the blue. But what if your data, if your distribution is something like this, which is like highly jumbled, right? Yep. So if you can see, the lot of data points is in the red points here, and few data points is in blue point here. But we can still at some point, or maybe some intuition, we can classify. But you can still see there are few blue points here, few red points in this zone. Yeah. So we will we'll see in a code like how we can attain the performance, how we can attain the accuracy, and all such thing. So now application of KNN. So as I told you, like enough, like KNN can be widely used in a lot of different sector, not only finance. Like let's say in your text mining, when you have the huge text data, so we have the specific technique called as NLP. But if you are comfortable with the machine learning, so we can use KNN as well. So but here we'll just talk about the this particular techniques, like like forecasting stock market, like predict the price of a stock based on company performance, measure and economic data, currency exchange rate, bankruptcy, credit rating, loan management, and stuff like bank customer profiling. So when you have this kind of like problem statement, so you can, like, without any doubt, you can use KNN. All right, so guys, that's all about our theoretical part. So now we'll quickly jump into our code and we'll see. Just give me a moment. Yeah, guys, I'm really apologize for my voice. My voice is a bit low today because I have cough and cold. So just please bear with me. Just wait a second. So guys, I think you must have able to see my Jupyter notebook, right? Yeah. So here we'll talk about the detailed code. So here the k nearest neighbor, like k nearest neighbor is basically, as we have discussed already, it's a simple algorithm that stores all your available cases, and we classify a new cases like based on a different similarity. Example distance function, and which is specifically like the distance. When we talk about the distance, so we actually, like, talking about the Euclidean distance, like the distance between a in a same group, in a same data points, one data point to the another. And the algorithm, a case is classified by a majority vote of its neighbor, right? Like we can identify the distance function. The most popular distance function are, as I told you, Euclidean distance. So we have this data set. So what exactly we have to predict? Like predict whether a given customer accept his or her loan offer based on the universal bank dataset. So there are around like 5,000 customers in the dataset and 14 variables. A brief description of the 14 variable are given below. So these all are different features or are different columns: customer ID, age, experience, income, CD account, and something like this, so on. And the last one, personal loan, which is this is what exactly I need to do with something. Like, did the customer accept the personal loan offered in he last camping? Like, let's say yes or no. This is our target variable, correct? So with this approach, we actually try to identify, like, whether the personal loan can be offered or no in any given particular customer. So we have the two classes here. One is yes and no. Yes, zero and no, basically. Like, so this is our target variable, correct? When we have the one, that means yes. When we have zero, that means no. So this is, I think you must have able to see my screen. Just ping me if you are not able to see my screen here. Hello. Yeah, guys, am I audible now? I think most of you, you guys are keep commenting that my voice is low. I'm not sure because I'm very close to my mic and I'm trying hard to speak louder. But if since my voice is low, maybe you can probably check your microphone also and your computer volume, because I think I have fixed from my end, but I'm not sure why the volume is low. Okay, all right. So in this data set, we are trying to identify and we have to find the personal loan, whether the customer, will accept the personal loan offered in his camping or not, right? So, like, according to his credit card, according to his past history, his education, his family, zip code, experience, age, considering with all this factor and how much annual income he is earning, considering all this factor, so whether the person will be offered to a loan or not. So we can see here the first line of first markdown, the first chunk of code, input OS, that is operating system, whether so we specifically you can use this code, use this import library for when you are working with any Windows or maybe a Linux. So when you are using operating system, so you can just import OS and import numpy as np, like as I have told you in earlier classes also. But yeah, again, so we use numpy for as numerical data pre-processing and pandas as pd for our label data pre-processing. And sklearn dot neighbors, sklearn we specifically use for our machine learning models. And we import k neighbors classifier. So here this is a classifier because it's a classification problem, that is why we use a classifier. But you can also use as a regressor, like a regression problem as well. Like as I told you, like the KNN can be used as a classification as well as a regression, but it performs really well. And when we have the classification problem, when we have the two different classes or maybe more than that, from sklearn dot preprocessing import standard scalar and main max scalar. So when we have to transform our data, so to get our more accuracy and to get the more sense in the data, we can specifically do this particular thing like a standard scalar. So these all are pre-processing steps. So there are ample of pre-processing steps, so you can go through in the previous classes, and maybe you can do your homework, you can get some data set, and you can just have a look, what all EDA you can perform. That is exploratory data analysis. Then the last thing, SQL and model selection, which kind of model we want, train test split, and grid search, cross validation score. Yep. So we have this data like bank pd.read csv. This is my path where I have this particular data set, and NA values, you can see like we have separated with this two thing. Like you can perform this thing in the next line of code, but yeah, I have just mentioned just to reduce, for the code reproducibility, like to make a more sense, like when you have to, when your target is to not to write like too many lines of code, so you can like perform in a single line. Like NA values, so I have specifically given if I have any kind of NA value which is separated by maybe a question mark or maybe a comma, so it will identify them. Print bank dot shape and type, like what kind of type is it? It is definitely a data frame, right? So bank shape, like we have around 5,000 rows, 14 columns. And if you want, you can also see the head, like what kind of my data is, like how my data is look like. Yeah, so this is my data. When you have the ID, age, experience, and you have around 14 different variables, right? Yeah. So now print bank dot column and bank dot d types, like what kind of column I have, and with each column what kind of data types we have. So we have around 14 columns here, and each has the different data type. Mostly like all are categorical, only this CD account which is category, like we all the data set we have numerical, but only this one is the categorical. Okay, there is no need for this chunk of code because I have already done it here. So like the bank dot head, you can see the head here, and bank education equal to bank education as type category. So like you have seen in the previous code as well, like why we use as type. So it is the simplest way to convert a column to a categorical type is to use as type. Like whenever you have, like the categorical value, we have to do as typing. So this is a, like this is the forced as type. When we have the categorical value, and we have to specific them, we have to specify them, like to a numerical, because our data, when we build the model, our machine will only understand the numerical terms, not any kind of the categorical terms. So that is why we have to given them with 0 and 1, or maybe any numerical value. That is why we have to do this as typing. Because if you see the education sector, the education can be different. If what kind of education we have here, maybe I'll have a look. Like, yeah, your education is like 1, 2 and 3. But if you see here, like your education level 1, undergraduate, graduate, advanced and professional. So this is something which is a categorical value, right? So my machine will not understand like what is education level 1, what is an undergraduate, what is advanced and professional. That is why we have to as type. So now you have to perform this as well. Bank equal to pd dot get dummies bank. So you can create a dummy variable. When we do this dummification, why we are doing this, when like if you can see, like you have around 14 variables here and 5000 rows and column. But the few, but since we have the few categorical variable as well, right? Like let's say the education, which is a categorical variable. So when we do this dummification, so whatever the categorical variables we have, it will convert to the numerical variable. Here we are doing as typing, like we are like commanding him, we are like forcing him to do a categorical thing, and here we are dummifying, we are doing a dummification. You do a dummification, and if you can just take a count again, like the head count, so you can see, like it change as education 1, education 2, education 3, like in this form, and cd account and all such thing in a different manner. So now if you can see, your column has been increased. Earlier it was 14, now it must has increased, we can see. And now you can also check, or maybe you can see here as well. Yeah, if you can see, like bank dot shape, which is 18 now, which has increased around 4 different columns, which is like this: education 0, 1, 2, 3, and earlier it was 14, now it's 18. And also we have to find the null values. See guys, like before everything whatever you are performing, if you want, like for your own understanding, like you can put one header here, like just above our 11th cell, and you can mention like what kind of what exactly you're trying to do, like you're finding the null values, or maybe you're doing a pre-processing, or maybe you are doing a dummification, or maybe like you are finding a columns, or maybe reading a data, so you can also do that. But these all are pre-processing steps, so it all will come together. So here we are trying to find bank.fill_na, bank.mean. So wherever I have the null values, it will impute with mean. So the, like So we are doing here like this particular thing. Yeah. So if you want, I can like show you also like how it will look like. So we get a print here like, yeah. So you can see like wherever we have the null values, it will fill with mean. So this is called imputation. So you can see like these all are means, like wherever we have the null values, because in my data we have few null values like this. Like say this is the null value, or maybe I could have a lot of null values. So whatever the null values I have, it will fill with those mean. So it will make more sense, right? When we have the mean, so again like it's like, because you cannot give your machine like any layman thing. Like you should give your machine like something, some kind of data, some kind of integer. Only then your machine will understand and like perform, and will help you to build a model. Yeah. So now we are splitting, like divide into train and test, like y equal to, so this is the just an like, this is an argument, so you can pass any sort of argument, like bank personal loan, x bank dot drop personal loan. So if you can see like every time whatever the target variable we have, so we have to drop the target variable. Okay, because that is what we are trying to achieve. So we don't want a target variable in my training data set when I'm building the model, right? And x is equal to 1, like because x is 1 means like my personal loan is in column, x is 0 means row. So if you don't specify anything, so it's automatically means it's x is 0. But you have to specify because we have to drop the specific column, that is why it's x is 1. Yeah, so now this is the like general thing I think I have already discussed in previous classes. X train, X test, Y train, Y test. So this is a splitting technique, like train test split X, Y, test size 0 0.0, 0.20. So when I'm giving my test size 0.20, it automatically understood. So my training has 0.80. So it is splitting into a 80 and 20. You can also do that. Maybe let's say you can do that 30. So it is to like 40. But yeah, it is really good. Like if you can given your data as like maybe 30 or maybe 20. So now after that you can again check your shapes, because now the shapes has been changed. Earlier it was 18. I have already dropped one column here. So now it is 17. Okay. So guys, if you can see here, like in my training, I have around 4,000 now, because when you split into a train and test, so automatically the rows will reduce, right? That is why it's like 4,000, and it's 17 because I have already dropped one column, which is personal loan. Print x test dot shape. On my test, like since I have around 5,000, so 4,000 distributed here and 1,000 distributed here. So this is just a basic understanding. I think you guys are able to understand, right? But if I'm see my white train dot shape, in my white train, I don't have any rows, and my y test also I don't have any rows, right? So this is scalar equal to standard scalar. So we have imported this particular library here. If you can see the standard scalar and the min max scalar. So this is just to like some kind of pre-processing and a transformation. So you can do this thing before your train and split, and you can do this after your train and split as well. Like it is up to you. And if you don't want, you can, like it is not specific to do, but if you do, so it will give you the more sense. That is why we are like specifically doing the scalar. So this is just an simple argument, so it can be x, y, z, or like anything, standard scalar. And scalar dot fit x train. So guys, this is really important to understand. Whenever I am fitting my model, you have to fit your model with your train data set, with your train, with your training data set. That is why it's, you cannot like mention your test. So whenever I am fitting my model, I am fitting my model with the training data set, because train is something which is a given data, which is a seen data. Test is something which is a unseen data. So we already have the seen data which is given. in our data set. That is why we fit our model first. Then xtrain scalar dot transform. So once you fit the model, so after that you have to, like, transform your model. So training and transform and then prediction. So these are the techniques we have to do when we build any model. So this is a one liner code for each and every item. Only thing which is differentiate what kind of pre-processing you have to do. The more kind, because this is a very simple data set, like, there are like, not much null values. We have only like 14 or 15 rows. So in this kind of technique, you don't have to do, in this kind of data set, you don't have to do much. But when you have the huge data set, so you have to do a lot of pre-processing, a lot of EDA, a lot of visualization to understand like how the things work. But since KNN, like, for better understanding, I just took this particular data set. So you can understood really well. Then after that, you can practice through maybe a Kaggle or maybe like somewhere else. Yeah. So now I will transform my scalar. This is the scalar. This is already which is given. Scalar dot transform x underscore test. So now I am transforming my data. This is just a warning error. You can ignore it. You don't have to. Like there is one library called, like, import warning, import version warning. If you just import this, so you won't get this error. Now we have to build our classifier, our KNN classifier. So model building model underscore, sorry, equal to k neighbors classifier algorithm brute. So brute, I'm not sure exactly what brute is algorithm, but yeah, this is the algorithm name. Yeah, and neighbors equal to 5. So what I'm trying to do, like, this is n neighbors mean this is our k. So I'm specifying k equal to 5. You can mention like k3, k4, k2, but it should be at least, like, some classification. So I mentioned here, and this is the hyperparameter. So you can, hyperparameter means which you select by your own. So you can select anything here. Now I'm fitting my model. Again, I'm fitting my model here. I have already fit my model, but with the standard scalar. But here I'm fitting my model. Model dot here. It is not a model fit. This is just a standard. You can avoid these two lines if you don't want. So model dot fit x train y train. We always fit our model with the x train and y train. Once you fit the model, then you have to predict. So guys, this is the most important thing when you fit your model, and you have to predict your model. So prediction means like whatever the things I have done, so how my model is performing, like how, what kind of prediction I'm giving. So when you do the prediction, because see here I have split my data into two. One is train and test. So I will fit my model in train, predict my model in test, which is around 20% I have given to test, so 80% I have given to train. Like y underscore predict, this is an argument, it can be anything, model dot predict x test. If you do, okay, because I didn't run this, I didn't fit my model, that is what is giving throwing error. Yeah, so now it has been predicted. So now that means your model is working perfectly fine. If it is showing any error, then you must have done some mistake like in your above code, so you have to recheck and just go through again. So now I can check my accuracy. Once you predict the model, and now you have to identify like how much my prediction is giving me, how much accuracy it is giving me, like what kind of accuracy I have achieved after predict the model. So for that, this is the code from sklearn.metrics import accuracy score, print accuracy underscore score y test y prediction. If you can see, like it is giving pretty much good accuracy, which is around 909, because earlier it was around 95, now it's 909 because the few chunk of code I didn't run properly. That is why. So you can just cross check. So we can so this is like all about our prediction and our accuracy. But you can also do this particular thing like grid search cross validation. So I would also like to talk about this. So grid search cross validation means, so the best way to think about hyperparameter is like setting up an algorithm. So like, Hyperparameter is something, so you can play around. You can play around here like a neighbor, like maybe a 5, 6, 7, whatever it is. So this is the hyperparameter which you can choose by your own to optimize my model, like even more better. So because 90% is still good, but what if you're getting around 98% accuracy or maybe 99? For that you have to just like do your hit and trial and try to achieve like whether I can achieve a more accuracy or not. So for that, this is the code: parameter equal to n neighbors list range 3 or 15. Like it means like a tuple and rows. Like you can tuple and rows, like I think I have explained you before. So if you can go through your previous lecture, so it will give you the more sense. Even if you have any doubt, so you can just ping me. I will, like, on a WhatsApp, I will explain you later. Like CLF grid search, neighbor k neighbor classifier, parameter n jobs 4. Here you can change, like, let's say 10 or maybe any kind of number, 6, 7, 8, whatever it is. Verbose CV cross validation 5, and clef dot fit x train y train. So fitting 5 folds, so for each of 12 candidates. What does this mean? Like this fitting, this is, as I told you, it is like based on the given tuple and rows. So like if you do this kind of thing, like if you fit your model, because you have already fit your model, but you are just changing your parameters, like just you are trying whether you can achieve a more accuracy or not. So if you can multiply like 12 cross 5, it is like totaling 60 fits. Earlier it was giving you only one fit because we have just fit our model only once. But since you have added this particular chunk of code, this line, so you can just play around your words. You can just play around your hyperparameter and you can achieve like totaling 60 fits. So when your model is fitting 60 times, it definitely gives you the more accuracy. Yeah, you can see here KNN model CLF dot best estimator print CLF best score CLF dot best parameter. The parameter which is given, which is around 3, and the best score, that is a k-neighbor score, which you are giving around 95%. So it is I think which is pretty good, right? Yeah, this is again like you can also check the accuracy score, y test, y predict test. So guys, that's all about today's class. It was a small data set, and you can also perform regression, but we'll not discuss about regression because I think it is good until classification. So if you have any doubt, you can quickly go through your code again and you can just ask me if you have any sort of doubt. So guys, we still have around like 5-10 minutes window. If you have any doubt, we can discuss about your doubts. Okay, so somebody has asked me, like, your variable is categorical, so most of the way put use to median for missing value. Yeah, that is true. Like since I have told you, when you have the lot of categorical values, so specifically you import as your median or maybe sometime mode. But since here we have only and only, like you can see, you can, there is a no way out. Like you can still still, like import your median as well. But since we have I just have only one categorical variable, that is why, like I have imported only mean. So mean will like do a really good job, but if you put median, so it doesn't have any harm. So you can like put median as well. How to decide the k range? So there is a no such k range here, like as I told you. So we can decide the k according to your understanding, like how you, because k is something which is a hyperparameter, and hyperparameter means, like, you can see, suppose in your basic understanding you can like just have a look, like whether I want to divide my distribution among 2, 3 or 4 or maybe a 5. right? So the less number of k you have, the better accuracy you will get. Yeah, and also use to random search CV for choose for better k. So we use this random search like that is a grid search to to achieve a better k. Like as I told you, if you can see the code again here, just wait a second. Just give me a moment. Okay, are you guys able to see my screen or no? Yep. So if you can see here, very small data set, that is why I have mentioned only five. So like to build your model and to evaluate your model. So this is grid search. It's something a combination of algorithm parameter and specified in a grid form, right? That I told you 12 cross 5 equal to 60. So it will give you the 60 different fits, right? Yeah. So guys, I think that's all about the today's class. Since even if you have any sort of doubt, so you can just don't hesitate to drop in a comment section, or maybe you can write a mail or maybe WhatsApp. I'll try to answer you quickly as soon as possible. Yep, thank you so much. Have a good day. Bye bye.